In this module, we will see some circuit diagrams coming together and operating. It's a chance to see how different components discussed in other modules work together. You'll also see how we can start with a simple circuit and add to it, creating safer systems or enhancing functionality. The first example is a simple circuit consisting of a single acting actuator operated by a push button. As you can see, when the button is pressed, the air flows through to the cylinder, pushing the piston rod outward. When the button is released, the spring pushes the piston rod back in, and the air in the system is vented through the exhaust. The second example uses a double-acting actuator. When the button is pressed, air is sent to the back of the cylinder, pushing it out. But this time, when the button is released, air is sent to the front of the cylinder, pushing it back, rather than relying on a spring. Air is exhausted through different ports depending on the position of the cylinder. Best practice would see unidirectional flow regulators to ensure that maximum flow is allowed into the cylinder, but flow is controlled when in the exhaust phase on each side. Now we will move on to a slightly more complex system. A double-acting actuator is operated by an air-piloted valve which is signaled by two switches. Rather than relying on a spring, this system uses signals from switches to move it both out and back in. This setup might be useful if the actuator was located on a roof, for example. Only small pilot lines need to come down to operator level. In some situations, a manual switch is not appropriate. It could waste time or lead to RSI, for example. This circuit has been modified to include mechanical switches, so the movement of the actuator would be automated depending on movement in other parts of the system. In this final example, a manual toggle switch has been added. It is best practice to add a switch like this to ensure that when needed, the actuator always stops on the in-stroke. This approach means stopping the outstroke signal rather than stalling the main air supply. That is the end of this module. The aim was to bring some of the theory to life, allowing you to see a circuit in action and confirm your understanding of how valves and actuators work.